Hello, I'm Richard Wright with LunarG. I'm on the Vulkan SDK team, and my primary responsibility is the Mac part of the Vulkan SDK. How many of you are currently developing for an Apple device or platform? Whoa, nice, nice. The rest of you are future Apple developers for the platform. I might be biased, but I like to say being biased doesn't mean I'm wrong. It just makes being right a lot more fun. So we're going to talk about what's the deal with Vulkan on macOS. How do we make that happen? How Molten VK gives you a layered approach. Several speakers have already talked the last couple of days about layered APIs. It works really great. How do you ship a Vulkan application on the Mac, since the Mac doesn't have a Vulkan driver? And we have two extensions to Vulkan that really help you out a lot on the Mac. These are not Mac-only extensions. When I talk about it, these may affect some Windows and Linux guys as well in the future. So what's the deal? Apple does things its own way, of course. Is this thing on? Is the button going? There we go. A bastion of openness. Apple is not. And, in the past, Apple works with IHVs, and they work on the Apple drivers. In the past, it was OpenGL was the developer-facing API. Now it's Metal. Metal is not an open standard, and Apple, of course, does what they want with that. It's their platform. I guess that's what we got to do. Metal is a low-level, explicit API, very much like Vulkan in some ways. And so, of course, a very simple solution. Let's just make an ICD for Vulkan on top of Molten VK. On top of Metal. I'm sure that Bill will tell you that was easy as pie to do. Ta-da, Molten VK. So now I see this a lot on message boards and chat rooms, like, oh, I know Vulkan, and I'd like to go to the Mac, but I don't want to have to learn Metal. You don't have to learn Metal to do Vulkan on the Mac. Looks just like Vulkan does anywhere else. There's a few holes in it, but it's not that hard to work around those holes. Anybody who's been developing software for more than a month knows that when you make portable software, you've got to check what version of the driver and what features are available, those sorts of things. So it's not really any different than running on any platform where you've got a variety of hardware implementations, or you want to move from platform to platform. So it's really very simple. All right, pardon me for a second. I'm a little confused by this layout. It's messing me up. This is not the way I practiced this 800 times. So, all right. So, if you're on a native system, you just write Vulkan code and it goes straight to the driver, and you're done. If you're on a Mac or on iOS or tvOS, you're still writing to Vulkan, same way. Only Vulkan is living in this package called Molten VK, which then calls down into Metal, which calls into the GPU driver. So it's really that simple. Yeah, right. So where do you get this magic library? For one thing, the nice folks at LunarG, we build the Molten VK for you, and we package it with the Vulkan SDK, and you can get that at vulkan.lunarg.com. You can also go to the Molten VK website and download it and build it yourself if that's what you're into. Molten VK sort of manifests itself on the Apple platforms 4 different ways. You can install a system-wide loader and ICD, just like you would get on Windows and Linux. We do not ship applications that way on the Mac. Why? It's probably beyond the scope of this talk, but it's really useful to do this for developers. And so the Vulkan SDK will do that for you on the Mac, and it's very handy. I'll spend a little bit more time on each of these in a minute. You can also include the loader and Molten VK in your app bundle. So you non-Apple people, Apple applications come in this package called a bundle. It's just a fancy directory, and it has all the resources, and you're supposed to put all your dynamic libraries and everything in this bundle. And you can put the loader and Molten VK inside that bundle and ship it with your application. You can literally have 1,000 Vulkan applications on a Mac, and each one has a different version of Molten VK. And if your app is tested to work with a certain version of Molten VK, you know, that can be a good thing. You can also link dynamically, include it in your frameworks folder. Frameworks is, again, it's just a special folder in the app bundle where you're allowed to put dynamic libraries. Apple is very strict about security. We can't just have DLLs willy-nilly all over the operating system. That's a security problem. If you don't like that, you can complain to Apple. They did not check with me. You can also link statically to the library. A lot of developers like to do that. Just link the Molten VK statically right into your app, and everything is all there nice and hunky-dory. Now, these last two options, by the way, these are your only options on iOS. So if you're making an iPhone or a tablet game, you have to use one of those. We don't have a loader or layers on iOS. That could change in the future. It may or may not be on my list of things to do, but we'll see. Not promising anything, right? Is my boss in here? All right. So when you install the Molten, when you install the LunarG Vulkan SDK, one of the options is System Global Installation. This copies Molten VK and the loader and all of the Vulkan layers into user local. So it's like a system-wide setup, and you're ready to go. This means VK, the Vulkan Configurator, just works. Vulkan Configurator is a really great tool. Christoph has talked about it quite a bit. It's really great for finding your Vulkan bugs you know about. Why is this doing something wrong or crashing? It can help you find improper usage of the Vulkan API. Also, bugs you don't know about. I frequently get reminded in my own code that I've destroyed my objects in the wrong order. And these are the things that sort of seem to work on the developer system and can kind of act weird when they get out in the wild. I'm sure a lot of you have experienced that as well. So again, these are API usage bugs. Let me go back. It's not like an integrated debugger, but it will let you know if you're using the API improperly. We do have layers on macOS on the desktop. The Khronos validation layer, probably the most useful. There's a couple of holes in there: debug printf validation and GPU AV, which stands for auto verification. I'm in some discussions with Bill. We're looking at maybe trying to fill that hole in down the road. The synchronization 2 layer, which provides synchronization 2 for implementations that don't have it native. And of course, the Khronos profiles, which Christoph has talked about quite a bit, infinitely useful, and the API dump, which may or may not be useful to you. So this is what a loader, what a bundle looks like on macOS. So your application, vulkanrocks.app. All it is a folder with a .app link extension on it. So the Apple people know about this. The non-Apple people don't. We have a contents folder. Frameworks is where all of your dynamic libraries belong. The macOS is where your actual binary is. And then you get a resources folder where you can put all of the runtime information. And in the Mac users and the Mac environment, that's sort of how we like to distribute applications. Everything is nice and bundled. You can drag things around and they'll run from different locations. We don't have, well, I'll just leave it at that. And in here, you can put the loader and the Molten VK library will act like an ICD, and it works just like the SDK install for the developer. If you want to ship your app with your own custom layers, you have to put them in this bundle like this to get them on the user systems. Oh, I forgot my little subtext. We have a getting started guide on our website, also part of the SDK, which goes into a lot more detail about how to do this and package all of this up. Another way you can distribute Molten VK is just include it as a dynamic library in your frameworks. folder in the bundle. Very simple. Some people are like, well, I don't want to update the whole app. I just need to update my dynamic library. You hear that all the time. There's lots of wars about whether that's a good idea. You fight it out amongst yourself, but if you want to do it, you can do it that way on the Mac as well. This works on all Apple platforms. This works on mobile and the desktop. You can just stick it right in there and link to it. This bypasses the loader. Molten VK actually has all the same entry points that the loader does. So it sort of fakes being a loader. One drawback to that, of course, is you can't load layers. So if you want layers, you have to use the actual loader and not Molten VK. Statically linking, Apple has this cool framework type called an XC framework. It actually has static libraries for all the platforms. So it makes it very easy if you're using Xcode and the Apple toolkit. You just include this framework, and if you build for the desktop, it links to the right static library. If you build for iOS, and tvOS, that sort of thing, so it automatically figures it out for you. And Molten VK builds one of these, and we package it with the Vulkan SDK. So just include that framework, and you're ready to go. And it has all the static libraries for you. And this is a great application. This is a great way to ship your applications with Molten VK just statically linked in. I am kind of a fan of static linking, but I realize not everyone is. This works on all Apple devices too, so you can build this way for desktops and mobile as well. And again, no layers. Even you can't call enumerate layer properties, that sort of thing either. You do get a layer. You get a Molten VK layer back, but you can't do anything with it. Okay, so that's it. No, I'm just kidding. That's not it yet. But that's it for how you package Molten VK in your thing. So what about the code? What does my code look like? There's two important extensions that you need to know about if you're going to target Apple. In fact, this goes for any layered Vulkan implementation on other platforms as well. It just happens to be that right now the Mac with the layered implementation is the largest layered implementation going on. And that's the Portability enumeration extension and the Portability subset. The enumeration extension, this is provisional, which is a nice way of saying this is subject to change, which means it will change before it ever gets finalized. The purpose of this extension is if you write a Vulkan app and you expect to get a fully conformant, full-featured Vulkan ICD, and somebody puts a layered Vulkan ICD on your system, and this can happen on Windows, not just on the Mac, and your game says, give me a list of devices. This non-conformant, not what you were expecting device may show up in that list. And a lot of people have very, very sophisticated device selection code, which is very simply explained. You take the first one you see. So you may get a driver that doesn't work with your game or your application. And bad things happen. And it's always your fault when that happens. End users, they don't want to hear stories about DLLs and things like that. It's always your fault. So this is a way for you to say, look, if there's some implementations that aren't fully conformant or have holes in them, I don't want to know about them. But it's also a way of saying, I am aware that there's an implementation that may have holes in it, and I do want that selected. This is more likely to happen on the Mac right now, but it could happen on Windows. We've got a lot of layered Molten VK. Sorry, we have a lot of layered Vulkan implementations showing up, and there's a lot of them in garages and different places being worked on. So how does this work? It's an instance extension, so you have to tell the loader ahead of time what devices you want to use. If you see this extension string in your list of extensions, it means you have a newer loader that understands the difference between fully conformant and portability or not fully conformant devices, and you need to take that into account. There's also a flag you have to add to the VK instance member when you do that. I'm going to show you some code in a minute. If you don't do both of these, you will get an incompatible driver or incompatible driver on the Mac, which means I can't find one, which is an error code. I would think it would just return 0 for the number of devices, but it actually returns an error. It's in the spec, it's in the rules, and they like us to follow the rules. So if there are multiple drivers and one's conformant and one's not, the non-conformant driver will not show up. So you'll only see the fully conformant one. And yeah, as I was saying a minute ago, this is much more likely to happen on Windows. I mean, right now it's happening on the Mac, but you may see that on Windows and Linux later. So I didn't want to really have a whole bunch of code up here, but this is sort of boilerplate code. If you're using the C interface to Vulkan, everybody's code sort of looks like this. You call enumerating extension properties to get the list of extensions. And then you go through the list of extensions and see if the ones you need are there. And if they are, you add them to some list. So here's standard C++ stuff. Add it to my list. And maybe set a flag or something. You can come up with something a little more elegant if you like, but just creating a bool and setting it to true works pretty well too. Then later on, when you create the instance, make sure not only do you need to add that instance string, but also make sure you set this flag, add that to your flags so that it knows. Now you've told the loader that you're okay with a portably conformant driver. Molten VK is working on becoming a portably conformant, so it's not like a good Vulkan driver and then some driver that doesn't work very well. A portably conformant driver has to follow the rules for portability. It has to expose what features are missing so that you know what's missing. Nobody wants to write code that, well, I may have triangle fans, I may not. So take your best shot and see what happens. So Molten VK is going to follow these rules so that you can query to see what's there. But we're not there yet. First of all, you have to say, I am interested in portability layered implementations. And if there are none, or there aren't any fully conformant implementations, you'll get incompatible driver. All right, so now you told the loader that you're okay with a portably conformant driver. Now what? Now we want to create a device, and we need this other extension, the portability subset extension. So one of these device drivers is missing things. How do you find out what's missing in this driver or what may be available? Because it could change from generation to generation of hardwares and drivers. This is a device extension, so it's part of your create device. The extension you look for is KHR portability subset. And you have to add that to your list of extension names when you call device create info. So again, more kind of boilerplate. You create one of these portability subset structures, and you pass it in your pnext, excuse me, in your get physical device features too. Now, get physical device features too, I got ahead of myself. This was an extension prior to Vulkan 1.1. So if you're targeting Vulkan 1.0, but you kind of expect to find this, you need to query for it as well and turn that on. So we have this structure, this device portability subset features. This is subject to change, but right now this is what it looks like. And they're just a bunch of flags that are on or off. This is a set of flags on my Mac M1. Let's see if I can get that to pop up. This could change. You've got a Mac with an embedded NVIDIA card or an AMD or Intel integrated graphics. These ons and off may be different. The next version of Molten VK, the next version of Mac on M2 or M3 could also change what these flags look like. So it's important to know that these can change. 0 means the feature's not there, and 1 means they are there, and they're subject to change, which means they will. You can expect that. All right, so you get the structure back. This tells you what's there and what's not. You do have to tell the driver which ones you want. So usually the thing to do is you just take the same structure you got that has all the flags set for what's available, and you just pass that in when you create your device. You could turn some of them off. You never know. I'm not sure there's a use case for that. If it says, yes, I support triangle fans, and you go, well, it's important that I let you know that I don't care about triangle fans, but I've seen weirder things. So I heard we were behind, so I did this pretty good. Molten VK is just a layered Vulkan implementation. You have to work around missing extensions, just like any other platform. I've been doing this since the OpenGL days. It's like, well, do they have OpenGL 3.1 or do they have 3.2? And unless you're in the games industry, you don't always have the luxury of saying, well, sorry, go update your graphics drivers or go get a new graphics card. Sometimes you actually have to make your stuff work on what's available. There are 2 portability extensions to help you get around this, and performance is very good. I'll let Bill talk more about maybe some gotchas with that, or you can talk to us after the fact. Try it. You'll like it. It's not bad. I actually build all my Vulkan stuff on a Mac first, and then I just put it on Windows, and I really don't have to do anything extra. It almost always just works on Windows. Be sure and catch Bill's talk, which conveniently is next. And also required by my employer, we have a great LunarG developer survey that we do every year. This is how we know it's important. Don't complain because we didn't do blah, 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 blah. If you didn't get on our forum or get on our survey and say, hey, why haven't you done blah, 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 blah. So this is how we know what the community wants to know. And we're held accountable to this. So we show this to the working group, and we go over what people are wanting and asking for. So please do that. It's very important to all of us, not just LunarG. This presentation is available online on the LunarG website. You can scan that code later. And the state of Vulkan on Apple devices is a white paper that goes into a little bit more detail about how the bundle gets packaged and the different ways of doing what I ran over very, very quickly. Any questions? Yes?
When you create the instance with the enumerate portability extension, why do you also need to put in the flag?
So when you create the instance and you have to pass in the enumeration extension, why do you also have to set the flag? So because that's what the spec says. Yeah, I don't know why they would add that. I don't know.
Second question.
Sure.
All of the libraries in the SDK for macOS are universal libraries.
Yes.
But the installer itself, I think, is only x64.
Yes. Okay, so good question. All the libraries in the Mac Vulkan SDK are universal, so they work on Apple Silicon and x86, but the installer is x86 only, so you need Rosetta to run it. Also, vkconfig is x86, which doesn't matter because it's only setting up a meta JSON file, and Vulkan hardware caps are also x86. So I'm going to say something, and then I'm going to ask a question. We're working on that. One of the tool sets we use for the graphical, is tricky to get to build for both. We're going to have to do it eventually. Second question is that really important right now, or just kind of annoying?
I just wanted to mention it.
Okay, you just wanted to mention it. No, we realize it's missing. We do a nice meeting with our boss every month. Here's the list of things you need to work on. That's on my list. So yeah. Yes, it runs fine with Rosetta. At some point, people aren't going to be having Rosetta, and it might be valid to say, well, I don't want to have to install Rosetta on my Mac. In which case, I have to say, well, forgive me for a little bit longer. We'll try to get rid of it in time. There was one over here. Yes.
Yeah. So we're on deploy for iOS devices, and right now development of the dynamic library is based in but far as I see, Apple is not too happy about that.
Okay, so the question, if I understand correctly, is you're doing iOS, you have to put everything in the frameworks folder. Apple will not let you put, there are no system DLLs you're allowed to touch or dynamic libraries. In my experience, it doesn't have to be a framework. It can just be a dynamic library in frameworks. And I know lots of developers who do that. And you can't have executable code in resources, but you can put it in frameworks. There's also a plugins folder, which is a magic name. You can put executable code in plugins, and that can also be dynamic libraries or even executables that your application needs to run. Can all go in plugins. Everything's got to be signed and notarized, and there's no getting out of that mess either. Okay. Yes.
Why do we expect small layer implementations on Windows and Linux?
So, are you asking why there's more layers available on Windows and Linux than macOS?
No, I mean layered implementations on Linux and Windows.
Oh,
Expected soon. Wonder why.
yeah. There's some projects to put Vulkan on DirectX currently. I'm not sure how much I know is under NDA or not. I'm just going to say there are projects by big names to put Vulkan on top of other things on Windows. And plus, even on the Mac, you could have Swift Shader, which is fully conformant. It's not fast. It depends on your application needs. You can have Swift Shader on a Mac and Molten VK, and Molten VK will show up as a portably conformant, but Swift Shader will show up as a full, fully conformant driver. Yes.
Might have talked about it, but I was just wondering. So you say that everything is designed in terms of execution code for its chip, right?
Yes.
And does that limitation apply to shader code as well? Do I need to recompile my shaders from Scooby into Metal SL?
Okay. So to repeat the question, we were making reference to the fact if you're on Apple, you have to sign and notarize your executables. All executables have to be signed and notarized before they can execute. And he's asking, well, what about shaders? Do shaders have to be signed and notarized? And no, I don't know how we get around that because they really don't like to ship. They really don't like engines that load code and execute it. But shaders are separate. And you could. They get compiled to metal, and Apple may have some sort of scrubber that looks over your metal. Bill, do you know anything? Am I wrong or about that? I've never bothered with it, and I've gotten away with it for years.
Well, because that's what happens with compiled shaders.
On consoles?
Yeah, you can't compile shaders.
Oh, you can't.
Yeah, so
You can do that on the Mac. I'm going to summarize since Bill didn't have a microphone, which is no. You don't have to sign your shaders. You can just load them and compile them on the fly. Works fine. Yes.
Just quick, so as far as I'm concerned, no validation is right.
There are no validation layers on iOS yet. It's something we want to see happen. It's subject to everything. It's all a matter of time and money. Anything could happen. In my past jobs, I've delivered a few iOS apps, and I always have a shell that runs my code on the desktop. And so right now, I'll run through my Vulkan on the desktop and use validation layers and make sure it's okay, and then I deploy it on iOS, and it works fine. Now, on iOS, we cannot ship, just to give you a warning of what may be to come, we still can't put validation layers and make them system-wide. So validation layers will have to be bundled in your iOS app. So during development, you could deploy to the device with the validation layer, and then when you ship, you could strip it out. Or if you had a layer that did something important, you would just ship it with your app, also in the app bundle. All right, I'm not out of time yet, but I'm out of questions. Going once, going twice. All right. I'm Richard at Luna G. If you have any Mac SQL problems,